All right, welcome everyone. We're back. We're live. We're in another stream with our guest here, Thomas, and our founder, Shashank. Thomas, can you tell us a little bit more about yourself and your company?
Yeah, of course. Hi, everyone. It's absolutely fantastic to be here. Thanks for having us. I'm Thomas. I'm one of the three founders at Origin Trail, together with Giga and Branimir. Yeah, I mean, we've been, in the Web3 space for a while. In the, let's call it symbolic AI or the semantic technologies space for even longer. So I'm happy to dive into both of this and cover a little bit more about how the Origin Trail's decentralized knowledge graph is what we believe to be a very, very strong addition to the AI agent stack, especially when it comes to making the memories of agents both verifiable and shareable. So I think this is one of the only moats we have left in the software space to be our memories. I'm happy to have this conversation. Thanks again for inviting us.
Yeah. So did you get started from crypto and then jumped onto AI, or it sounds more like you started with AI and then started using crypto wherever it added value to the AI itself?
Yeah, I'll say, like our background came from knowledge graphs. So very much focused on ontologies and constructing this kind of graph structures that were essentially very useful for organizing data whenever there were a lot of connections. And it figures out that the world revolves around connections in many, many different ways. A lot of things are natively graphs. So anything, if you think about how the world of global business or any other vertical basically functions, it's all about who's connected to what and what has happened. And if you want to like a rich context about anything that has happened, you will likely have a good time using a graph. So that was our beginning, and then we started using graphs for which is kind of, if you look at AI, this symbolic AI branch, right, which was also quite prominent up until the last 5 or 6 years when really the neural networks exploded like crazy. The good old-fashioned AI.
I think we can help the audience understand symbolic AI versus neural networks a bit. I don't think.
I think it's a very good distinction because it almost functions like a yin and a yang, right? It's two parts of the same thing. So semantic or symbolic AI is very much more deterministic. So we're talking about ontologies. We're talking about creating symbols that describe meaning of data. So they describe the actual the true representation of what a person is, a position is, an entity is in a graph. And because we can create connections between things, these connections are also carrying meaning. So you can then create basically these types of deductive systems where you don't have to populate everything, but you can deduct from these rules that you're enshrining in ontologies a lot of new data that you otherwise wouldn't. And that's the beauty of the symbolic side. And of course, when it comes to neural networks, the very big breakthrough that was achieved is that the fact that these networks were able to be trained on so much data that the patterns of this statistical AI, which is probabilistic, so it's not precise, but it's a very, very good guessing engine. They became so strong that actually almost give us a feeling of being deterministic, or at the very least give us some reasoning capabilities by using these patterns. That is a very, very strong way of using basically what we have today as large language models or visual models or any other type of neural-based models that are just a fantastic tool to run reasoning and to kind of outsource this statistical intelligence part. But you put them together, this is where you're really winning, because you can have the strength of the symbolic and you can have the power also of the neural, which is what we were kind of like swimming towards.
How do you put them together? Is it like agents themselves are like LLMs, so they use neural networks, and underlying there's memory of knowledge graph where they update based on looking at the world. Is that how it is, or like?
Yeah, I see you guys are at Fraction AI are also using context graphs. If I caught it a little bit, so it's like that's the neurosymbolic play right there, right? So you would have you use the neural networks for what neural networks are good at, and they're great at this reasoning, right? And they're like breaking down tasks and organizing it and finding what's the best way of kind of which the best pattern fits the challenge that it was given to solve, and it comes up with great things. But then on the other side, what's the kind of counterpart of this is the memory, right? So how can we persist what has the neural network achieved so far, but also how do we organize it so that this neural site can really leverage it on an ongoing basis? And here it started with, the retrieval augmented generation using embeddings initially, right? So it was like RAG was all the thing, and we were chunking. And to some part, we're still doing that. So, and look for similarities between chunks and what the objective was. But very quickly, the similarity in words is a very dense field, right? So because the same word can be used in so many different contexts. So then graphs start to really appear as something that's really powerful. And for us, this was a natural thing to happen because Origin Trail was building graphs all along, right? So we were like, okay, this is obviously going to be a more performant thing. And then GraphRag became kind of like a moment. And then that really solidified as a context graph memory component where the entire memory of an agent is structured into a graph. And then uses that connections and that nice organization of the data to really have a persistent way of organizing anything from traces of how decisions were made to what connections to outside world, and organizing the data that came in from different data streams to what other agents were doing and so on. So like you can really, it's just a memory. It's a very, very flexible component.
Yeah, I mean, so for the audience, one of the things about neural networks is that they have memory. Their weights are the memory, but it's distributed memory. You cannot tell what each weight means. Like combined together, they mean something, but like by itself, it's like some representation we know nothing about. But in case of knowledge graphs, you have entities and relationships. So entities could be companies, and relationship could be this is the buyer from this particular company, or this person sells to this company, and then you can have all sorts of relationships between all entities. So it's easier to reason about knowledge graphs. You can even look at a knowledge graph and tell what it's representing. You can identify if there's any issues, like updated over time, and it's easier to make sense of the relationships between different entities. Whereas in neural networks, it's you can't know what it has learned and what kind of relationship it's learned. So we were talking about combining the two and how we can use knowledge graphs to store the knowledge, reason about that knowledge, and neural networks to work on top of that as probably as agents and doing all sorts of evaluation on top. You want to add something?
Yeah, no, I'm just like, maybe the one thing that you were really going here with is like the explainability, right? That we get with it. It's like how to understand also what the agent does. Like how can you trust the source of the decision? What was it based on? And with these graphs and the connections and what we have like as knowledge assets is how you can pinpoint exactly who and where did the particular data point that the decision was made on, where was it sourced.
Yeah, definitely. And I say that because one of my projects in an earlier career or life was creating knowledge graph for financial entities. So we had one of those clients, a hedge fund, who wanted to see the most relevant news about their portfolio. So we had this knowledge graph where there were entities, and then there were suppliers, clients, and those connections. So not only did they see news from the company they had bought stakes in, but also the companies that were connected to those companies, because if that gets affected, then this gets affected. So more comprehensive news based on the knowledge graph we had created. So yeah, it was super useful.
Nice. Yeah. No, so many nice use cases for it. I think like when you start, when you start looking for graphs, you kind of see them everywhere. So it's a little bit of a bias as well, but definitely can be a lot of help in structuring it with connections first.
Definitely. Okay, so where does the crypto part comes in?
Yeah, man. So like we were doing knowledge graphs, we became the problem we wanted to solve because we wanted to break down data silos, and then we became a data silos. And then we open sourced everything we've done so far. So in 2017, we kind of, we couldn't unsee the idea that Bitcoin brought to the table with, you could send the financial assets from one side of the world to the other without the banks sitting in the middle. And then you had Ethereum kind of coming up with, you could actually do some compute using the same infrastructure as well. So for us, it was very natural to kind of want to achieve the same, and nothing really went in that direction yet, because our world was all about this data and graphs and everything. And like everyone was just dealing with like spaces in blocks and whatnot, which was good for what it needed to do, but it wasn't like where we saw the big value. So that's where Origin Trail originated as a decentralized knowledge graph. And we basically did a network which used blockchain for fingerprinting the data, so that if you have your knowledge graph and I have my knowledge graph, and my agent looks into your repository for some inputs and vice versa, we want to make sure that the data we're reading is actually not tampered. So if I made a claim last month and you're reading it now, you want to make sure that I haven't changed it just before I delivered it to you, but it's actually from a month ago. And the DKG with the blockchain fingerprints just allows you to have that tamper-proof record of when a particular claim was created and that it hasn't been tampered with. And then we used blockchain to basically build or spawn this the decentralized knowledge graph infrastructure, which was then relaying among all of these different, let's call them edge knowledge graphs, and create one connected global knowledge graph between all of them. So that launched in 2018. And since 2000, I'll say then 22, all of the use cases of using the decentralized knowledge graph moved from being static dashboards or something that's just, like here's a credential and you check it out or something like that. They all moved towards being the conversational window being the interface to the data, because it gave much more flexibility. LLMs in the beginning, even as a standalone, could create some Sparkle queries or other type of queries towards the graph underneath to retrieve good responses. Now with more advanced things that we're seeing, obviously agents can continuously come up with different ways of accessing, querying the graph, adding to the graph, enriching it, and doing a whole bunch of good stuff with their graph, using it as a memory, right? So I'll say that, these were kind of like the main phases. And for us, the Web3 element it's a trust infrastructure. That was a key. We couldn't do it without trust. Then it doesn't make sense, because without trust, how will you be able to create a system that is decentralized, where there's no single entity keeping the control of all the data? If we want to take that away, which we are very much believing is the only way that we can have an inclusive and truly scalable system. When it comes to, even if we look at the data today, and you were saying before how neural networks are created of weights which are like traces of memories of the training data that they were trained on. But what were they trained on? Still majorly on publicly available internet data, which is not high quality. It's also limited in size compared to everything that's under the surface. And this is where the really high quality stuff lies. And if we want to engage that data, we need to have it in a decentralized way, because no company will just go and sell or give access to data to any single AI company, or just give it away because it's their moat. That context is there. That's where the value resides. So we need a decentralized approach to activate that data and to activate the real value of AI systems. And if we want to do that, we need to have a trust infrastructure. Without it, there's no way of doing it. And here is the biggest Web3 opportunity or one of the biggest Web3 opportunities out there.
Yeah. So a few questions there. So is there one big global knowledge graph, or everyone has their own knowledge graph that somehow connects together? Like the subgraphs connect together in the global graph.
Yeah, it's a one graph. So basically, it's a one decentralized knowledge graph network that connects everyone together. But very importantly, there's different layers of privacy. So with V10 now, what we're getting is basically every agent has 3 main layers of how they're handling their memory. First layer we're calling working memory, which is their local thing. So they don't share it. This is something that you can think of it like, agent going and constantly reshuffling it and like doing different manipulations to it. Once it feels that this is good enough to be contributed to a shared memory, it can bump it up. Now, the shared memory is where within a particular task, objective, project, or one context graph, if we want to call it like that more precisely, that context graph can be shared with other agents. So, but that is by permission. So I only allow yours, or it could be set to public and anyone can join. Let's say that we all want to do an open source intelligence network on bad actors in Web3. So we can launch one context graph that everyone can subscribe to, and we will take care that only who has good reputation and not, and who's doing what type of additions, and we'll have automatic deduplications and stuff like that. All of this is handled by the context graph, but all of this resides in the shared layer. That's the layer number 2. And then the layer number 3 is the one that is called the verified memory. The verified memory is when you're anchoring it on chain. When it comes to the point where this memory is something that has value, and you want to make sure that this is actually provably so in the future as well, this is where you then push it towards verified memory. You use track basically to compensate the rest of the network, and anchor it on chain. And then all the agents that are accessing verified memories, they're able to make sure that it hasn't been tampered with. Now, this becomes crucially important when we're talking about context graphs that get monetized. So think of it, an agent wants to subscribe to your context graph about news on a hedge fund activity. They are able to do it automatically via, let's say, a protocol like X402 or something like that, where they can just settle that payment on chain, receive access to your context graph that you have populated with this verified memory, and then they're able to basically query it for it according to your rules that you've set up. And then when they are no longer either paying or the time has run out or whatever, maybe it was a one-time access, you just remove them from the allow list, and they're no longer able to see your context graph.
Okay.
Those 3 layers, the working memory, and the verified memory, is where the permissions are operating in. But everything together is one single network.
Okay, so how does an agent decides that it needs to go from level 2 to 3? Like it could share that data, that context graph to others before. How does it decide that it needs to now make it verifiable and on-chain?
Yeah, so it could be driven by a use case. Let's say that the agent wants to, it's building the reporting thing that you were doing for a hedge fund, right? Now, this task, you've outsourced it to the agent, and now you want that agent to anchor stuff that it actually found at a given time, because that's a part of the proof points that is delivering the value to the hedge fund. Whether was I the first to find it? When did I find it? Has this been captured, but then it was deleted, and now I'm raising this piece of news to do. So if you want that level of the audit logbook of the actions and the decision traces of the agent and how they've transpired, what you want to have is verified memory. And then you will just set it up. You'll tell the agent, okay, use verified memory because that's my value proposition towards my client. And I want to do it. Alternatively, in a more, let's say, DeFi trading scenario, where there's signal being accumulated by the agents around a particular trading pair or a particular movement, they could build out the context graph, and they would want to put it into verified memory because they want to monetize it. So the idea is that no other agent will likely want to consume data that they don't know if it has been infested with some rogue inputs, that they cannot check if it's actually true or not, because if there's monetary implications to it, the risk is too high. So if you want to have something that is scalable way of making agent-to-agent context graph access to be carried out, it needs that level of trust. And then that just becomes a use case for verified memory. So I would say it's either monetization or it's use case driven, where trust is an important element of what you're trying to achieve that will make you bump it up from shared to verified. But even up until shared, we still want to have origin trails should just become like the agents today feel like they're in a single player mode. It's like you're using Microsoft Word and then you're sending this Microsoft Word to another guy and he's working on it, and then it's back and forth. What Origin Drill brings is now we're multiplayer. We are in the collaborative tool space. Agents can actually work together very efficiently. So it's not just about plugging in your Obsidian. That's just step number one. But what if we both plug in our Obsidians? And now what can we do together? Like that's the big shift, and then starts to happen.
Yeah, nice. So when you go from level 2 to 3, like what kind of checks and balances are placed to ensure that the data is trustworthy and it's the level of trust is higher than level 2?
Basically, you would be able to define that. So it's more, we don't want to introduce a certain how to say it, like one of our core principles is neutrality. So when it comes to even local context graphs, you can choose a graph database. We don't prescribe it. When it comes to what is like a requirement to move from one to the other layer, like from level 2 to level 3, it depends on the context graph you're building. And you will be the curator basically of that context graph is the one that decides what is good enough or not, and will it allow it to go up or not. Because at the end of the day, this is also where the funds spent are associated, right? This is where you expense track to use when you jump to verified memory. So given that there is a spending of track happening, that curator who owns the wallet with the track is the one that decides, okay, this makes sense or this doesn't make sense to be added into the verified memory. But yeah, I think it's a very good question, kind of like what. Because if we're talking about monetization context graphs, and I'm having my trading bot need to rely on the data that you're putting there, I'll be interested in what's your threshold, principle. What are you allowing to be there as like a good enough data so that my bot can use it and leverage it, and since I'm paying for it. Yeah,
definitely. Which industries have you seen the most adoption for verifiable memory?
It's a good question. We have traditionally came from global trade, so I'll say that there, it's like that those transitions are happening, and they're very much like the enterprise sector understands why they need this type of verifiable memory, because if the other side is that the compliance will just not work.
Yeah.
If you don't have verifiable memory, like you cannot just do things on an off chance that they will work right. So I have my, Mac Minis here. I play, but this is for personal, entertainment type of things. This is inconsequential at any scale. And for those things, you can consider that security and compliance is kind of like it's a setting. It's a matter of what my setting and what my permissions are. But when we're talking about this becoming either multiplayer game, or it becomes something where the finances are included, and it's a thing between two entities, or an enterprise setting, then it becomes a question of the infrastructure. And this is where the DKG really plays a role. So I'll say that these types of enterprise adoption we've seen quite a bit. I'll mention just a couple of use cases that have been using the DKG for quite a bit. Is in US, you would have Walmart, Home Depot, Costco, and many other US importers using the decentralized knowledge graph to manage the context of the overseas factories audit reports. So that became a context how that needs to be consumed by the decision systems within those importers. Am I buying from the right factory? Or what they're now working on as well is to expose these data sets to the CBP, right? So the Customs and Border Patrol, so that makes it for an easier import into the into the US. In UK, you have British Standards Institution. In Switzerland, Swiss Federal Railways. Plenty of research and development projects in the EU are relying on this infrastructure to use it. So I'll say that's the one bucket there. The one I'm quite keen to see that is now kind of gathering more momentum is that there's more single developer or smaller teams of developers that are building solutions either they need for themselves or for their immediate clients. Which previously were kind of like a bridge too far potentially, but now powered with AI coding and having a bunch of agents, they make it more sensible. And there, I'm sure you see it as well. Like the context bloat, you start to implode on your projects, and then you're like, oh, the further down the rabbit hole you go, you're like, shit. Like, do I just blow everything up and start from scratch, or can we salvage it? And a lot of these things is just how you manage context and how you manage memory. And for them, having something that you like a spine that you can rely on as a shared context graph that is very nicely organized and very sturdy, and it's almost like a checkpoint save in a game. When you pass it, it's like, okay, game saved. Right. Even if we screw it up from here, like we can still revert to something that's like it's verifiably here, and we know that this was a good place we were at, and we know the decision traces of how we came here. So you just get much more insight into how the systems work, and that can help you be more efficient. And we see now there's also a Telegram group of these builders because the V10 is only coming out now, right? So this is like a very, very fresh system that's getting released in these weeks. Yeah, we see a lot of them playing with even the testnet now and like building out cool stuff. Yeah, maybe another one that's big and has a quite strong backing is called Humanitech. It's a company that deals with protecting like using this AI trust infrastructure to purpose it for safe AI. So it's starting with this protecting the identities of individuals and companies and brands online. It was co-founded by us and as well by Porsche Piech family office, and received support by quite a sizable group of investors going from West Coast of Silicon Valley through East Coast and Europe and the GCC. And that's where the context graphs around particular high-profile users become something that's like really needs to be like have verifiability, because those forensic graphs, they are not only used as a way of depicting it to the users, but they're presented to the platforms to take down harmful content, as well as towards the law enforcement agencies to then persecute, or to the courts to sue for damages and similar. So like this becomes totally non-trivial use of the technology. And yeah, I think it's one that will have a lot of implications, not only for the first use case, which is very strong, but also more like across the entire safe AI supply chain that the product will likely evolve into.
Yeah, and having them as graphs also gives you more context, because if they were just tables of, say, people who have done wrong things on the internet, it's just few people there, you don't know if they're connected to others or any potential other people you could pursue. But in case of graphs, you can also find other potential people you could go after. So yeah, more context in general.
100%, man. Yeah, I've seen it also. I'll just end on this point, is like that you see it in action too. Like if you like you made the juxtaposition, if there's a single post that you try to take down, okay, it's a single post effort. And for that, for example, it took Humanitech, I think 8 hours to take down a non-consensual material that was online, and then it reappeared. The same perpetrator wanted to do it again, and because we had the graph of connected assaults basically happening within a spread of time, the platform took the second thing down in less than, I think it was 7 minutes. So like that's the effect of the graph, right? Because you have full context and you can present that full context versus just saying, oh, hey, here's another thing that is disjointed. So 100% aligned with you there.
Nice. Okay, so do you have libraries that work specifically with OpenClaw or Hermes?
Yeah, so basically V10 is, the idea is to have a lot of what's called like adapters, basically, to let you weave in your agent and plug it into the memory of the DKG directly. So literally 2 commands. That's it.
So
yeah.
Can I do Hermes add BKG and it works?
So you could, I'll give, like, I think we can then either post it underneath as well. So there's you just point your agent to our to the DKG V10 Git and tell it to obviously, like, it's nice to check the code as well because it will give it full context of how it can use it. And then with the 2 commands, you would get full set of DKG tools available within your agent, and it will have a skill included as well, which tells it how to use it basically. Then you can try to force it one or the other way. So some like to use it more as like a handoff memory, where it's just, okay, now this is the actual learning, and I want to hand it off to the graph, so it's kept there and persisted for longer time. I'm actually even more prone to just be like, just plug it straight to like core memory, just MDs, don't do it. Just go full graph, see what's happened. It's a bit more. Agents aren't natively used to it yet. So like giving them strict instructions with skill and like tuning them to really learn what your patterns of using is the best is something that is worthwhile investment to do it in the beginning, so that you know that you get repeatable results. But even out of the box, these things will work pretty well. And then you can you can basically start using it. It becomes also connected to your UI of the DKG. So when you open up the 9200 port, the /UI, you'll have ability to connect then your Hermes straight into that UI. So you can chat with that same instance of the agent through DKG UI as well. So you don't have to flip back and forth between whatever else you're using to contact your agent, but you can just do it straight there. So there's a few things that, yes, make kind of, we try to bring it closer together, and you can have multiple agents on one node as well, right? So you have one DKG hosted on your either virtual machine or at home, and then you can, like, I have my Hermes and my OpenClaw connected to the same DKG node, and they're both, and they have separate memories, right? So they're separate agent memories. They're just using kind of like one modem to connect to the network, and then again, the installation or the adding is the same as it is in other case. You just show them, like, install this, and they shouldn't make it was done so that they could do it autonomously, so you don't have to even play with terminal. But if you want to, it's 2 commands and you should be good to go.
Nice. So instead of having memory like markdown files or just storing it as text, they then store it as a graph, a combination of text and graph, or in the second case, just as a graph.
Yeah. And actually, we've done now, it's not even just for agents. You can even connect it to like Codex or to your Claude. I've done it now for Claude Desktop. Now, these different type of tools and frameworks, it's like, for Claude, it's based on MCP. So you won't be able to eradicate their MDs because they won't, like, you don't have the access to meddle with how their memory really, you don't know what's in that memory. So that's another whole rabbit hole to discuss, like that, how memory management is important, because in a lot of cases we have no clue what really is kept in the full context of either one chat conversation or across multiple conversations in a given service. So, but you can add it as well, right? So you could have your Claude code talk to your Hermes, talk to your OpenClaw, and they can all share one context graph between all of them working together on one project. So you could have one agent be the builder and one could be the tester. And so, and they can both kind of access and write their findings into the same graph, one understanding what the other saw or learned from, and so on. So this is kind of like think of it, you can build like teams of agents that don't have to be confined to a single provider. Like you can launch several Hermes agents within one Hermes instance, right? So you just like, I don't know what the commands are, but like you can spawn multiple. But here we're talking like you can just do, also multiple different providers of agents, or whatever this, I don't know, sometimes you want to do OpenAI and Claude together. So here's like a common denominator that you can use in the middle to connect how the things work. Multiplayer.
So it's like team members share a Google Sheet between them, and then they're all writing to it and saying, "Yeah, bro, remove this." Agents are doing this on knowledge graphs.
Yeah,
right?
That's it. That's the idea.
Yeah. Also, I was happy to hear your thoughts on how the growth of agents for crypto native tasks, like doing all sorts of transactions on chain, mainly around transferring stable coins or managing all RWAs that have been coming on chain over the years. Do you think it will be mostly agents? Like the transactions done by agents will outnumber of those done by humans in due time? And if so, what role will knowledge graphs play in powering those agents?
Yeah, I'm like majorly bullish on agents being users of Web3. I think there's a group of enthusiasts who liked the UX of our the wallets and checking the hashes and doing all the shit you have to survive in this space. But to be honest, like in a lot of ways, it almost feels like it was built for agents. You have this machine readable verifiability. You have this kind of like a management of different keys and ability to spawn so many more wallets for like different, like either you want to have more privacy or you want to have more traceability or more precision or whatever. Like humans, it's tedious to do this, but agents, it seems like second nature, right, to do it. So when it comes to like outnumbering transactions, especially if we're talking in the world that we were describing right now, where the task at hand is how can we onboard the long tail, or if not even the long tail, but the first majority of users to really become like inclusive users of artificial intelligence, likely is via leveraging the Web3 tech stack, and then leveraging it in a way where we don't force feed them, hey, now download this wallet and use this, but it's going to be as a part of the AI native stack where this will just happen, and like things will just be done in the back, and people will be interfacing with value has been transacted for the return of data or for access to a service. And I think agents will have much easier task of opening up a wallet than a bank account anytime soon. So it feels just very, very, very like natural extension of the agent activity to not only be used for pump and dump schemes, but also to be used in like more actual use case scenarios where such transactions make sense, or even investing. Like why not have an agent that you feed different strategies in, and they can, again, with explainable mechanics, think instead of you on what type of actions should they make. Like they already think instead of me on finding, I don't know, nice places to stay, visit, or good technologies to use, or how to manage this and that. Like why wouldn't I also have their suggestions or even actions be done on financial matters, and giving them some level of autonomy to execute those via the Web3 stack. So very, very much seeing that future, believing in that future, and I think we're building components that are supporting that future as well. So like I mentioned before, the X402, I don't know if that's the standard that's going to be prevalent for handling agent-to-agent transactions, or if we're going to need anything specific like that, or it's just going to be like your simple transactions. We'll see what really kind of ends up being the thing that is most interesting, but something will. For that, to me, is quite clear. Yeah, that was the first part. Sorry, I forgot the second part of the question. There was
like the advantages of sharing knowledge graphs between them. Like,
yeah, I mean, for as a catalyst of this adoption, I think there's just so naturally tied to it, because that is the, like, if you think of, what are the resources that agents are going to be buying, like what would they buy? What do agents need? Like they don't necessarily need things for cloud. They're not going out for a new Lambo. Very hard for them to enjoy a Lambo, right? That's very much a human thing. And but what they need is they need infrastructure. So they need like compute. They're going to need some storage space and stuff like that. So this is something that they might be interested in obtaining. Majorly though, it's data. Like that's what they're hungry for. That's their like bread and butter on how they make good decisions, on how they stay up to date, on why do we see this incredible jump in even latest versions of what is being offered through OpenAI or Anthropic. It's not part of it. Definitely is that the LLMs are, as foundational models, are getting better, although feel somewhat commoditized, but they are improving as the whole industry is. They're all improving, right? Maybe for a month someone has the edge, the others kind of pick up the slack. Open source comes sometimes in front, sometimes a little bit under, but as a commodity, everything kind of flows up. But the big jumps, they came from either tools, they were able to have some autonomy, or they have data, because they have some high quality stuff to feed you, because they have access to sources, because they have access to like actionable things that they can do. And this is where it feels that value for agents really lies. And how do we make that data seem attractive? It needs to be discoverable. Knowledge graphs, great for discoverability, especially if it's a global one connecting everything. It needs to be structured, so it's easily consumable and checked if it's good or bad. Again, structured graphs make a good candidate for that. And it needs to be trusted. So it cannot be something that you just generated because everyone can generate it, right? So I need to make sure that you haven't generated on the spot, but this is actually something that was contextually relevant, produced when it should have been. And this is where the whole verifiability element comes into play. And now you have all these three elements, possibly even created across multiple agent swarm activity. Okay, another agent is now willing to pay. So, and this likely is the most valuable piece of resource that the agent could wish for. This is their Lambos. And now, of course they're going to spend on this, I think. And I think
unless Lamborghini allows agents to drive their cars, like if agent could go in and actually control that car, then maybe Lambos.
Maybe, I'll pull back that statement then, and I'll say that Lambos may be. Plus, we're partners with the Porsche Piech family, who is the owner of Volkswagen or controlling shareholder, which also owns Lamborghini. So I cannot talk badly about the car, anyways.
Oh, nice. Oh, I thought it was the other way around, that Volkswagen owned everything.
Volkswagen is the mother, or like the umbrella company that owns Lambo, and it owns Porsche, the company. But the family owns the Volkswagen, so at least the controlling shareholders.
Oh, nice.
So
great.
That was a long deep dive into that, but Lambos being on the buying list or not, I think the like context graphs for trading agents, for healthcare agents, for manufacturing agents, for booking agents, for whatever, teaching, any vertical will need to have access to high quality data, which is like, I wouldn't trust data on public internet majorly today to do any of these decisions. So this isn't really connected yet. And like, can we make it connected as something that Web3 enables this exchange of value? If that's the question mark, I'd say that it's a bet I would be willing to make, that we have a role to play here that's significant, and that the DKG and like Web3 rails are placed well to address those needs.
Yeah, nice. Exciting times upcoming. So we're almost out of time, so let's move on to the next section, the rapid fire round.
All right. First question is for you, Thomas. So, what's the origin of Origin Trail? How did you get to that name?
Man, that's a good. Well, I was asleep, so I can say that I unfortunately I cannot take the credit, but Branimir and Giga did manage to whip it up, and they woke me up. Then I think it was like 2 a.m. Because we were obviously doing with transparency technology, and then like they were like Origin Trail. I'm like, yeah, great. I went to sleep. So, but it was fantastic name, and I'm so grateful for them to come up with it. But it was not a play on Oregon Trail, even though a lot of the the US folks who were big fans of that game thought that maybe there was a innuendo there, but no, it was more about the trusting the source, hence Origin and hence Trail is why we were putting this forward.
All right, that's nice. Next one is for you, Shashank. So, an AI agent that does not use a knowledge graph is like a trader who?
Can't explain why they took a particular decision.
Okay.
That's a
So
good
from
one,
now on, all questions are for both. So whoever wants to take it first. And the first one is a little bit spicy. So there is a theme that we were talking about just like recently, which is agent-to-agent transactions. Can agents trust each other without human input, human guardrails? Let's say your agent Shashank wants to buy a Lamborghini from Thomas's. Do you know that agents can like screw each other up without any human guardrails?
Thomas,
I'll go first. Then I think we're putting a lot of stuff in place so that would be possible. So I'll have to be an optimist here, and I'll say yes. Using the DKG, you can come pretty damn close with it.
Okay.
Yeah, as far as the technology goes now, I guess there have to be guardrails. We cannot give agent direct access to the internet, direct access to all APIs available on chain. So it has to run in a sandbox where it can only do certain things, and that set has to be big enough that it can do useful things, but has to be limited enough that it cannot like send all my capital to some random wallet. So yeah, there has to be a balance in between.
Yeah, that's fair. So this is like in a similar way. As agents start working together, what do they need more? Memory, reputation systems, or payment rails? Like, what is the most urgent?
You can go first. I took the last.
Okay. Let's go through them one by one. What was it? Reputation system?
Reputation system, payment rails, or memory?
I don't think payment rails, because we already have pretty good systems. Doing payments on blockchains is pretty easy. It's an API call, so I think that's solved. Reputation system, it's not that difficult. You just have to look at all transaction history of an agent, see how it did based on what you wanted it to do, and see if it's good enough for you. If it is, just use it, or look at the context of that agent and see if that is what you wanted, and then use it. Memory is probably more important because that's what makes the agent better over time. Memory is where you provide context, so it can outperform other agents, because underlying most agents are same. If they use the same underlying models, they are effectively the same. It's only the memory and context which actually makes it different. So yeah, memory is pretty important there.
Yeah, I'm slightly biased. I'll go with memory first as well. I just think like capturing both the decisions as well as the full context of what the agent has is almost also a prerequisite to be able to gauge the even reputation then fully. And then when we have reputation and memory available, we have grounds to make good use of the payment railways, which to Shashank's points, I agree, it's majorly we've solved it. The hard parts are already done there.
Okay, talking about solving things, what's the one thing that if solved, it can help the agentic economy scale faster?
I'll go for, I think it's the trusted shared context. I think the big one is that a lot of agents are still, or more or less all of the agents are currently sequestered. They're siloed. They're doing things on their own. If it swarms, it's limited types, or a very vertically integrated thing. So the big thing is when we can, I think, connect more agents through shared context, allow them to exchange it. This is where we can get some fun things going, especially for scalability.
Yeah, I would say trust. For everyday people, they feel more negatively about the failure cases than they feel positively about whenever agent does something right. So even if you have like one thing going wrong for 99 done right, it just still reflects negatively. So as people use them, they understand how it works, and the agents do stuff what they're supposed to do. I think just people just move towards them.
Okay, so the last two questions, one of them is about trust that you're mentioning, Shashank. So in regards to the AI industry, which one is an actual threat and which one is just an annoyance? AI hallucinations, deep fakes, and model collapse.
That's a good question. I'll say that hallucinations. Well, if we look from AI industry perspective, then hallucinations are something that needs to be dealt with, and by combining it with strong context, we can curb a lot of it quite well, or at least make it so explainable that it's highlighted. The deepfakes, they're one example of a very harmful use of technology currently, because there's not a good safety infrastructure in place. In a lot of ways, I compare us to like being in the early days of e-commerce online, when we were putting in the credit card details, and there was just sent to a guy in the basement. When we had now the PayPals and the Stripes of the world erupt and like cover this infrastructurally, it became much more safe to operate, and e-commerce could really boost online. So with AI, deepfakes are one example of harm that shows to the lack of safety infrastructure that is out there, because just creating a generative image or video isn't bad in its own right, but creating it so that you're deceiving and spreading misinformation is a problem. It's a big problem. And if not solved, I won't say just deepfakes, but deepfakes and other harms related to that could be the thing that makes AI slow down quite a bit, because of the regulation being much more harsh in response. The model collapses, they're cataclysmic, right? So this is what we've seen since the 60s. It was rise and then sharp decline, rise and sharp decline, because we ran out of data. So I don't think we're at that point now, and the systems are stronger than they've ever been. There's a lot of thought being put in place to make sure that these types of collapses don't kind of inure. But to really defend against them, again, we were talking with Shashank before, having access to this data below the sea level, which is currently not accessible. And if we can have an inclusive way of getting to that, then this is a pretty good counterweight to the model collapse probability.
Yeah.
All right.
I definitely agree with the hallucinations part. Regarding model collapse, I would say it's more than data. It's historically there have been a lot of AI winters, and they were about like high promises made, and then the models weren't able to keep up because they were not able to learn as much and perform as good. And then there were a time of winter, and then again there was AI hype, and so that is kind of going on. But with LLMs, that doesn't seem to be the case. They are continuously getting better and better. So I don't think we should see an AI winter unless we hype it up in such a way that we are not able to meet those expectations. Thirdly, I don't like the word hallucination. It's the model is just wrong. It's not hallucinating. It's just saying the wrong thing. So let's just call it what it is. The model has been wrong. In some cases, that could be thinking of some things that didn't exist. sometimes it knows the answer, but like gives you a wrong answer. So like just call it wrong answer. So I believe that's just a function of training. As the training methods get better, as AI begins to also look at data sources before giving an answer, also starts giving answers like I don't know what it is, which is a perfectly good answer when you don't know. So yeah, I think those problems will get better. For general people, I would say getting right answers is more important than anything else.
All right. So we almost arrive at the end of the hour, and the last question for both is about communities. What's your most memorable moment with your community?
Oh man, there's plenty to choose from. Origin Trail community has been around for a bit, and it's very welcoming. So whoever is in our corner of the internet, they're very welcome to join in and come hang out. I'll say some of the fondest memories come from our in-person events. So there was the DKG Con, which I'm sure Fraction AI is going to be coming to as well when we put the next one up. But we ran one in that was New York, which was great. Just the setting and the folks there were incredible, and we had Dr. Bob Metcalf joined our community there as well in person, so that was sick. Amsterdam as well, Ljubljana. So I think there's I would just DKG Con occurrences. I'll call them, let's say, one of the highlights when it comes to community hangouts, and I love the mix of the building vibes and people just talking visionary stuff.
Awesome. And you, Shashank?
Yeah, I mean, for me, it's always fun when people use our platforms in ways that I hadn't thought of. So, like always looking at power users doing things which I was like, oh, our platform can do that is like the best moment for me.
True.
Yeah, that's awesome. Well, we arrive at the end of the hour. Thank you so much, Tomaz, for joining us. Thank you, Shashank. Everybody, please follow Tomaz and follow Origin Trail. And thank you all for joining today.
Thank you. Thanks for having me again.
Yeah, thanks a lot, Tomaz.
Bye-bye.
Bye, everyone.